Okay, guys, so work period today. So here's what I would like you to try these. You can do more than these if you want or less. I'm not really sticky on it, but my recommendation is to try at least what I put up here is a good idea because it kind of covers everything we do. Number 13 is a little bit different, so I'm going to give you a little hint on that one here. So in the part one, do 1, 3, 5, and 7, and then 13. That's the 5 there. And then in part two, 2, 4, 6, 8, 10, 12, 14, and 16. So if you're looking at that, that's about, what is that, 5, 8 there. And then 22, which is a little bit of it. So let's bring these over here. Okay, so just these 2, 4, 6, 8. Notice when you get to 10, you're going to have to expand that out first, okay? Because we only know the power rule. We don't know the product rule yet. So you're going to have to multiply that out first and then do the, once you get a polynomial without brackets, then you can do the derivative, okay? And in 13 here, it says find the slope of the tangent line to the curve here that equals 0. So what you have to do is take this derivative. Once you've got this derivative using the power rule, equal the answer to 0, and then factor it and find out what your x is. Once you find out what your x is, there should be two values there because you're going to get a quadratic for the derivative. Once you find out what your x value is, then you plug your x back into this original equation to get your 2 points or 1 point or whatever it might be. In this case for 14, there's 2 points, one at 2 and one at -2. So that's how you got to do it. You got to take this derivative and then equal it to 0, and then find the values of x where it equals 0, which is basically quadratics. Okay, when you get into here in part 2, I'm getting you to do the even stuff, 2, 4, 6, all the way to 16. So make sure you're converting these into negative values so you can use the power rule, and this one into a positive value because it would come up to the top. Okay, and then I also have you doing 22, which it says find the equation of a tangent line to the curve where x is at 1. And we did an example of that exactly. So first thing you have to do is take the derivative, find the point first of all, take the derivative, and then once you have the derivative, you've got plug in 1, get the slope, and then use the line equation. And that's what I'll get you to do. Okay, just being cautious here. You got to expand that one out if you're going to do that one, but using the power rule. Okay, so that's what I want you to do. Go back to that original line there. 1, 3, 5, 7, and 13 in the first part, 2, 4, 6, 8, 10, 12, 14, and 16, and 22 in the second part. Okay, so good luck.